Okay, this is the, I don't know how far we're going to get into section 9.5, but we'll see. This is 9.5, graphs of sine and cosine functions. And Mallory, if you're watching this video, you might be a little bit confused because I'm going to go through this a little bit faster with these guys that are here in class because they know what I'm talking about and you're not going to. So come to me with questions, okay? I'm going to give you guys like the front-loaded like information on sine and cosine, right? We've talked about this in trig last year where this is the graph of the sine function where he does one of these. And the graph of the cosine function starts up at 1, goes down, and then comes back up, right? Okay? And the period of each one is 2 pi. So it takes 2 pi before it starts to cycle back over again, okay? Now, let me kind of explain to you how they get these numbers from, okay? So if you have your unit circle in front of you, pull up your unit circle, okay? And what we're going to do is we're going to analyze the graph of sine first. This is the sine function. So we're looking at 0 being the x-coordinate. And we say, like, what is the sine of 0? Okay, if you look at sine, what is sine of 0 on your unit circle? So go over to 0 and look at the y-coordinate. What's the y-coordinate at 0 on your unit circle?
1. 1. Or wait, 0.
0, right? 0 is at 0. Okay? 0 is at 0. Now, if I go over to pi over 2, okay, which is up to pi over 2, what is the sine value at pi over 2? 1, right? So they're graphing it according to the unit circle. Now, if I go to pi, what is the sine value at pi? 0. So we're back down to 0, okay? If I go to 3 pi over 2, the sine value there is -1. And if I go to 2 pi, the sine value is back at 0. So it's kind of like taking the unit circle and it's elongating it. And then rather than it going full circle, it's just stretching it out along a y-axis, right? So it's doing that. Same thing with cosine. So if we look at like 0, what is the cosine value at 0? 1. So it's at 0, 1. Okay, if I go to pi over 2, what's the cosine value at pi over 2? 0. So we're down at 0. If we go to pi, the cosine value is -1. So we're down at -1. If we go up to 3 pi over 2, or down to 3 pi over 2, I guess, on the unit circle, the cosine value is 0. So we're back to 0. And if we look at 2 pi, the cosine value is 1 again, right? So it's just taking that unit circle and it's elongating it out so that we have, that thing, okay? Now, the important thing about sine and cosine, the cycles go forever to the left and to the right. This is just one chunk of it. So this would keep going, blah, 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 and left and right forever, right? Okay? But if you look at, I'm going to erase all my markings. If you look at the sine graph, let's say he continues going like this and he does this. Cosine is just this chunk from here to here, right? That's what cosine is. So it's just taking like sine, and to get cosine, we've just shoved him over a little ways, right? And he's starting like there and vice versa, right? So they're just like shoved over from one to the other. Does that make sense? Okay? All right, so normal sine graph, normal cosine graph looks like that, okay? Happy with that? I'm gonna have you go to the top of this paper, and we're gonna write out, I'm gonna give you all of the information that we're gonna learn in this section, okay? And this is kind of a rundown of what we did last year, okay? You will have functions look like this. Y equals a sine, and it could be cosine. I'm gonna put cosine in parentheses because it doesn't matter. It could be sine or cosine of bx minus c plus d, okay? So anytime we graph a sine function, you will have any one of those elements, a, b, c, or d, okay? Sometimes you'll only have things that look like maybe like 3 sine of x. In that case, you only have an a value, right? You don't have to write that down. Sometimes you'll have like sine of x plus 6. In that case, you only have a d value. Does that make sense? Okay? But worst case scenario, you have all of those things being graphed all at the same time. Whoop. Erase. All of those things happening at the same time. Okay? So let's talk about what each of those pieces does. Okay? So the A and the D, these are the easy ones. Those are the easiest things. Okay? A tells you what the amplitude is. Okay, and the amplitude is how high it goes and how low it goes. How high or low. In other words, it is a vertical stretch or compression. It tells you how high or low it goes. The amplitude is how high or low. And you don't have to do anything to that number. It's just how high or low it goes, right? That's just the thing. Okay, let's see if we have an example down below here. Right here, yes. Example, graph y equals 1/2 cosine and y equals 3 cosine. Oh, are shown below. We're going to graph them below, okay? So, we're going to graph them below. So let's get a graph going here. And, yeah, we'll do that. Okay, normal cosine. I'm going to graph like normal cosine over here. Normal cosine starts up here at 1. And then it comes back up to 1, right? And here in the middle, it's down at -1. So it crosses like this, and then it comes back up like that. That's what normal cosine looks like. And this is 2 pi where it ends. So I have pi, 2 pi, that's what normal cosine looks like, okay? So when I have a 1/2 in front, that just means I'm half as tall, okay? So this is 1, this is 2, this is 3, this is -1, this is -2, this is -3, okay? So now if I'm doing half cosine, I'm going to do my little markings. I'm going to do 2 pi over here. We're going to do pi right here. Okay, those are my middle pieces. Okay, if he is half as tall, he's going to start up here at 1/2. He's going to go down, and halfway through the cycle, he's going to be at his lowest point, which is -1/2. Okay, and then he's going to go back up to half at 2 pi, right? And in between those is where he's crossing in the middle, right? He's crossing in the middle. So I think it's helpful when you're graphing sine and cosine to graph those kind of like 5 dots and then make your cycle from that. Does that make sense? Graph those little dots and you know, whatever. That's what he looks like. Something of that nature, okay? That's what my cosine value will look like. So he's really short. That's what the 1/2 does. It changes the amplitude, okay? Changes the amplitude. And usually when you change the amplitude, if you're thinking about like sound waves, amplitude is going to make it lots lower, right? Versus if I make the amplitude really high, it's going to be a really high-pitched voice, right? You have like lots of range in your sound, lots of pitch in your sound, okay? So that's what 1/2 will look like. Now if I change that to be a 3, so this is the 3 cosine, I'm going to go up to, okay, I'm going to go up to 3, and I'm going to go down to -3, and I'm going to go up to 3 again. Technically also the pitch of sound, like, is a horizontal stretch and compression too, so if you're horizontally compressed, you're going to be a higher pitch versus if you're horizontally expanded.
Those, like, compression waves instead of like the aren't sound waves like compression waves and not like the transverse ones? So like we learned about that in physics.
What's that?
Like they're like there's compression waves and there's this kind of waves. They're going to these transverse waves, and like the compression ones look like the I don't know. They don't look like this.
They don't look like that? I don't know. I have no idea. I don't know.
What's the use for?
I don't know.
I don't know.
I don't know. I don't know. I don't know.
Sorry.
I don't know. You could be right. I'm sure you are.
I don't know.
But the other kind of waves, the formulas for them are going to be kind of using these similar traits, like the amplitude would change, whatever. But it won't be sine and cosine probably. Like the sound waves might be a different function other than that. Okay. So if we're doing 3 cosine, it goes up to 3, down to -3, and back up to +3. Okay. Some similarities, they're both going to cross the x-axis at the same time, right? Both cross in the middle there, but it'll just go up higher and down lower. That's what my amplitude will change. Okay, good? All right, and then let's talk about, I'm going to skip around. Can I skip around? Because I'm going to do the easiest ones first. Can I skip around?
Sure.
Let me see if I'm allowed to skip around.
Are they gonna like add each one to example?
No, I can't skip around. Okay, the next thing we're going to do is D is the other easy one. D is a vertical shift. Okay, and this is another one that's really easy. So if it's like +2, we're just going up 2. If it's -3, we're going down 3. Vertical shift, you're just shifting your graph up and down. And that is all. Okay? That's the other really easy one. And then these ones in the middle, B and C, are kind of painful. They're kind of pain in the butts. B is going to tell you what the period is, okay? AKA the horizontal stretch or horizontal compression of a function. It tells you how wide the cycles are, like of a period. Okay? Period, horizontal stretch or horizontal compression. Okay, now, this number doesn't tell you exactly what the period is, okay? There was a trick to it, okay? And I'm gonna write this in a different color. This is the rule. The rule is that whatever your B value is, you take 2 pi and you divide by that number, whatever this number is, you take 2 pi and divide by that number, and that gives you what the period is. Now, do you remember why it is 2 pi from trig class? The normal period of sine and cosine is 1 full cycle is 2 pi, right? It takes 1 full cycle before it gets back to the beginning again, right? And then it starts over, right? So 1 full period of sine or cosine is 2 pi. So we have to, so amplitude is just done for us. Vertical shift is just done for us. Those are the easy ones. But the period, we have to kind of hunt for a little bit. And the period's change is going to be 2 pi divided by b. That's the new period change. Oh, Marcus, you should listen to this.
I don't want to.
This is gonna be so,
I want to.
so far ahead when we get to trade.
I know, he's going to be so far ahead when we get to this. All right, anyway.
I will not, because I'm
Ah,
not.
Mallory. It's going to be so far ahead when we get to this. It's going to suck right now. I'm sorry, Mallory. But you're going to be so far ahead when we get to this, okay? All right, so 2 pi divided by b. Let's do an example down here. The graph of blank is shown below. When it's not shown below, we're going to graph it. Okay? But I'm also going to graph regular sine on here as well. Okay? So regular sine goes up to 1, down to -1, and it starts at 0. Okay? And it ends at 2 pi, and halfway between is just pi. Alright, just like that. Okay, that's what he looks like. Alright, so we start down here at 0, and then he goes up to 1, he goes down to pi, like down to 0 at pi, down to -1, back up. So this is what normal sine function looks like. This is just normal sine. Okay? Alright, and then they say graph sine of x over 2. Are we good? Are we doing okay? First of all, x over 2, I don't like the way that that's written. What is that, and how can we write that better? Sine of 1/2 x. I'm going to write it like that. So now I can say that the b value is 1/2, right? B is 1/2. So I have to figure out the period of this thing now. And normally period is 2 pi, but in this case, the period is changed, and the period is not 1/2. I have to do the funky formula to it, okay? The period is actually equal to 2 pi divided by 1/2, right? 2 pi divided by b, and that gives me the new period of it, right? Okay, but if we do 2 pi divided by 1/2, it's like 2 pi times 2 over 1, because it's a key flip, and that is going to be 4 pi. So, what have we done with this function, with normal sine? We've stretched him out, okay? Now, that is always true. It's kind of the reverse effect. It's always true that if you have numbers that are smaller than 1, like 1/2, it actually makes him wider, right? If you have like a number that's bigger than 1, like if this said sine of 4x, that's going to make him skinnier, right? So big numbers make him skinny, small numbers make him fat, right? That's just the way that it goes, okay? It's kind of like slope. If you have slope that's higher, bigger slope, it's going to be more straight up and down. If you have slope that's like a smaller number or a fraction, it's going to be wider. All right, so 4 pi is my new period. So I'm going to, I need to make some more markings on here. So I need to stretch them out a little bit. And I have 2 pi, and 4 pi is going to be twice as far. Okay, and then what's this marking here in the middle of that? 3 pi. Okay, so he's making 1 full cycle in 4 pi now, not just 2 pi, right? Okay, he's still going to start at 0. Okay, and he's still going to end at 0 on 4 pi. Let me do this, and there you go. Start here, end here. And he's going to come back in the middle at 2 pi. But he goes up, and he goes down, and he looks like that, and there's my 5 dots. Do you see my 5 dots? So he's going to be lots wider now. Okay? He's twice as wide as he was before. Is this making sense? Yeah. Maybe. Is this making more sense than it did when we did it in trig? Yeah, good, good. Okay.
It makes like the same amount of sense.
Do you think it's the same amount of sense? Because at least I try hard.
C's the one that gets, yeah.
Okay, happy with that? Okay, happy with that? Then the last thing is the C value, and this is the stinkiest of all. So A and D are my easy ones. Those are like the first two things that I tackle, A and D. B is like the third thing because that's like a little bit harder, and C is the last thing because he's like the uckiest of all. Okay, so here is C. C is there. Okay, and C, this tells me my horizontal shift. Basically left or right. And these are yucky. If I'm going left or right at all. Okay? But it's not just this number that tells me that. It is if there's no B. It's just that number that tells me that. But if there is a B and a C, then it's kind of yucky because I have to do some work. And the work that I have to do is, the formula is the horizontal shift is equal to negative C divided by B. Negative C over B tells me my horizontal shift. Yeah, negative C over B tells me my horizontal shift. Okay? So, that's the breakdown of worst case scenario, they put A, B, C, and D in there, right? They put it all in. Worst case scenario. Most of the time, they'll only have you do like one or maybe two things, okay? All right, let's go to the back side, negative C over B, keep that in mind. Here we have this stuff. All right, so example, they want us to graph this thing. Graph this thing, all right. Let me do it in black. There we go. I should just do these, there we go, look at that, look at how beautiful. All right, okay, so let's identify the variables that we have. Do we have an A in this function here? Yes, we do, and it is 1/2. Do we have a B?
1.
Technically 1, right? 1 is the B. But since B is 1, then that means that my period is not changing at all, right? Okay. C is negative pi over 3, right? That's what he is. That's what C is. And D, I don't have a D. There's not a plus anything out here, okay? So this is what I like to get into the habit of doing, okay? Anytime you have a function like this, just to organize my thoughts, I say A, B, C, and D, and then I write next to them what that tells me, okay? So A is 1/2, and that means my amplitude is 1/2. Okay, so that's how tall he is. B is 1, and that number tells me what my period is.
So it's too high.
But I do 2 pi divided by B to get the period, which is 2 pi over 1. So the period is just 2 pi. Yeah. Okay, so I know my amplitude is 1/2. My period is 2 pi still. Okay. C is negative pi over 3. Okay, and that's going to tell me my horizontal shift. Sometimes they will call this the phase shift. I want to bring that to your attention. Phase shift. If they say that in the book, that just means horizontal shift. Phase shift, okay? So horizontal shift, but to do that, I have to do negative C over B, okay? So negative C over B, this is the tricky part. Negative C will be negative pi over 3, and my B value in this case is 1, right? So that just turns him to plus pi over 3, right? Plus pi over 3. And so in terms of a horizontal shift, that means that this is pi over 3 units to the right. Because now it's positive. So it's pi over 3 units to the right. Okay, does that make sense? All right, and D, there is no D, so no vertical shift. We're not shifting him up or down at all. Okay, all right. Okay, so, all right, here's my graph. We have sine is what we're graphing, and we have to, yeah, we've got to do some things. All right. All right, normal sine, I'm going to graph normal sine up here in red instead of on the same graph. Normal sine does this, and here he ends at 2 pi, and here's at regular pi, and he's up to 1, and he's down to -1. That helps me just visualize that this is what sine is, okay? And so, he normally starts at 0, but since my phase shift is pi over 3, now I'm going to be scooted over pi over 3 units. Pi over 3. I'm just going to put pi over 3 there, and that's where he's going to start. Does that make sense? Pi over 3 is where he is there, right? Now the period where he ends at is maybe the next thing that I want to do. And then I can kind of block off where the middle section is. 2 pi is where is how long he is, okay? So from here to the end here is going to be 2 pi, right? From there to the end. So I have to figure out where he's going to end at, okay? So I take pi over 3 and I add 2 pi to it, right? Or I add 6 pi over 3 to it, because that would be a common denominator. So where am I going to end? 7 pi over 3. So I'm going to be over here at 7 pi over 3, wherever you want to end it. Okay, 7 pi over 3 is right there. And then I need to block off my halfway point. So what is halfway between pi over 3 and 7 pi over 3? Okay? Finding the halfway point is kind of like finding the midpoint, okay? Finding the midpoint is like adding them together and dividing by 2, right? So 1 pi over 3 plus 7 pi over 3, that would be 8 pi over 3, and divided by 2 would be 4, right? 8 pi over 3 divided by 2, this is 4 pi over 3. Does that make sense? Yeah? So that's where he's going to go. And I'm just going to label those 3. I'm not going to find this middle point right here because it's going to be kind of gross. Okay? Pi over 3, 4 pi over 3, 7 pi over 3. Okay? All right. And normally he starts down, goes up to 1, down to -1, and back up to 1. Except the only other thing that I have to deal with is the amplitude is now 1/2. Okay, so I'm going to mark off 1, and I'm going to mark off -1. That's not centered here. Let's do this. Come on. There's my -1, there's my +1. There he is.
I lost a tenth.
And then we have to go up to 1/2 and down to -1/2, right? So start here, up to, let me do a different color. Start here, up to 1/2, down to -1/2, and back up. Yuck. That's a lot of stuff. Okay, good? Good? Okay, do you want to keep going, or do you want to stop and then do the last couple examples tomorrow?
Can we stop?
Stop? Are you ready to stop? You're snowed? Okay. Otherwise, I'll, yeah. Okay, we'll just stop. We'll finish the next 2 tomorrow, and then I'll just give you the rest of the time to work. Okay, tomorrow? Okay? How's that? All right.